A personal journey into climate change. 2 decades ago, September 1997, I was part of a major scientific project in which we planned to man a Canadian icebreaker drifting with thick sea ice in the central Arctic for a year. The purpose was to study the surface heat budget of the Arctic, hence the acronym SHIBA. The location coincided with that of an earlier project called AJEX, done in the mid-70s, in which I participated, and data from which became the basis of my doctoral thesis. Based on that experience, we expected the trip into the ice to be a rough one, bashing against thick ice floes. Instead, we more or less glided through ice that was often only a meter or less thick, and in fact began worrying about finding a floe that would actually last through the next summer. We finally did find a floe, about 2 meters thick, and then began the arduous task of setting up our instruments around the ship. Sometime during that first week on the ice, I was asked to sit for an interview with reporters from a network morning show. The interview was long, and I was very anxious to get back to the work of putting my instruments in, but I understood the importance of trying to convey to a large audience why we were there, to understand why climate models were very sensitive to sea ice, and why it appeared that polar regions were like the canary in the coal mine for global warming. Within a couple of days after the media interview, we were able to start the SHIBA ocean profiler and get the first samples of upper ocean temperature and salinity. That evening, I looked over those profiles and compared them with data from AJEX in 1975. And I had trouble sleeping that night, returning again and again to the thought that our grandchildren might see an Arctic free of perennial, that is, year-round sea ice. What kept me awake was trying to reconcile the emotional versus intellectual sides of being a scientist. Just days before, I had tried to explain to what might be a national television audience how our craving for fossil fuels could change one of the distinguishing polar caps of our planet. And we were here to better understand what role rather esoteric processes like the ice albedo feedback would play in that transition. The analytical side of me understood and accepted those physical arguments, yet there was still something essentially conservative in me that rejected the idea that our species could change something as fundamental as the Earth's climate in the short span of a few decades. Yet, here was evidence that things were indeed changing, perhaps faster than we had ever thought possible. Here I have to explain a bit of the science. The ice albedo feedback concept is relatively simple. Ice reflects a large fraction of the incoming solar radiation right back to space. It has high albedo, whereas the ocean with low albedo absorbs most of it. Consequently, if cracks appear in the ice, then the open water absorbs solar energy that would have been reflected, increasing open water, melting ice, increasing the open water more, melting ice again in what's called a feedback loop. On a global scale, solar radiation reflected by ice and snow plays a major role in climate. Oh, well, what about the interview, the Good Morning America interview that I envisioned would teach millions of people about the ice albedo feedback? My 15 seconds of fame comprised mainly answering 2 questions. Have you ever fallen in the Arctic Ocean? Yes. Was it cold? Yes. By comparing those initial SHIBA profiles with the earlier AJEX profiles, I determined that the amount and distribution of low salinity water in the upper ocean indicated that a lot of ice had melted in the summer of 1997, implying that there had been a strong ice albedo feedback. I returned from the ice that November and wrote that up as an article that was published the following spring. The title of the article included the phrase, "Is perennial sea ice disappearing?" The question posed in the title was controversial, and a few of my fellow scientists gave me flack about it, because at the time there was little indication that sea ice was indeed disappearing. September is when sea ice reaches minimum aerial extent. And in the previous year, 1996, the ice extent was the largest observed in the satellite measurement era since 1979. Nevertheless, I was able to convince myself and my co-authors that my explanation for the thin ice and very fresh upper ocean passed the Occam's razor test, and subsequent events have certainly justified posing the question. So how did I come to a point 2 decades ago where I was lying awake in my bunk aboard an icebreaker in the middle of the Arctic Ocean, pondering the world my grandchildren would inherit? Given the extreme events of the past few months, millions of acres burning in the West, California's hottest summer ever, hugely destructive hurricanes, one after the other, the Indian monsoon gone crazy, I wonder how many people, including many here tonight, are going through similar thought processes. Are we seeing the start of something that we don't completely understand, but that may change everything, and not just for our grandchildren? I wanted to be a scientist ever since I was in grade school. I love the process. I won't call it the method, I'll call it the process. And it can be summed up in 4 words for me: observe, imagine, hypothesize, prove. Each of those steps is vitally important. If you cannot prove the hypothesis you formed from what you observed and imagined, then move on. And that is the beauty of science. It always moves on. During my first year in graduate school, as I was leaving his office, a favorite professor asked if I'd like to go to the Arctic. I jumped at the chance, and that brief conversation shaped a career spanning 4 decades of research on air-ice-ocean interaction in polar regions. The work included over 24 field projects on sea ice in the Arctic and Antarctic. On some, we landed aircraft on the ice and set up our stations, often building them ourselves. On others, we worked in Arctic fjords, surrounded by astonishing scenery. Sometimes, if I had poetic talent that we heard earlier, Svalbard is the place that I would write about. It is just a wonderful, wonderful place. On some of the projects, we worked from ships in the ice, drifting with the ice, sometimes over a week from the nearest port. During these projects, there was never a time when I didn't stop to marvel at the environment. Conditions ranging from beautiful cold blue sky and white ice as far as you could see, to raging blizzards with hurricane-force winds and temperatures far below zero. As the models predicted, the Arctic has become sort of ground zero for global warming. Temperature there has warmed at a rate more than twice the global average, and in the past 2 decades, there's been a startling reduction in sea ice extent and thickness. So this is from the start of the satellite era till now, and you can see that the pack at its minimum has lost more than the area of Alaska. I was in a rather unique position to observe and write about some of these changes firsthand, but I think I should point out that I didn't start my career with an intense focus on climate. I was interested in turbulent boundary layers, and drifting sea ice was a wonderful natural laboratory for studying them. In the 1970s, the Arctic seemed just as cold and as ice-covered as it always had been. Then in the 1980s, I had the privilege of working and talking with scientists who were analyzing ice cores from the 2-mile thick Greenland ice cap. They were really excited by what they were finding, and it was really hard to ignore. The 100,000-year climate record that they were reconstructing from air bubbles in the ice showed that up until about 10,000 years ago, the climate was sort of like an angry dragon, thrashing its tail about, huge swings in temperature and sea level, sometimes on very short time scales. So this graph is starting on the left 100,000 years ago, and then looking at the temperature as taken from the ice cores in Greenland. And just as a point, you can see that the temperature rises are often quite a lot faster than the falls. Then about 10 millennia ago, climate settled down. We entered what is called the Holocene epoch. I thought this was really cool. It seemed to explain something I had often pondered. Why, in the long time span our species has been around, did civilization as we know it develop only in the last few thousand years? Well, here was an answer. The climate dragon went to sleep. Temperature and sea level stabilized. Agriculture and commerce had a chance to develop. But there was a dark side to all this. The ice cores indicated that climate could be chaotic, and that minor perturbations could trigger big changes. It wasn't very well understood, and I would say still isn't, how these changes could occur as rapidly as they did, on timescales of decades. By the 80s, we also knew that burning fossil carbon was increasing CO2 in the atmosphere at exponential rates. It had been known for a century that increasing CO2 would increase surface temperature. Scientists like Jim Hansen started pointing this out and arguing that developing alternative energies would not only slow the warming, but might actually spur the economy. Then something strange happened. The issue jumped from being a scientific discussion to something that became highly politicized and eventually highly polarizing. This defies reason. What impact could ideology possibly have on the physics governing climate? During March 2008, I was part of an international polar year project designed to map conditions in the upper ocean over as much of the Arctic basin as we could reach with ski-equipped Twin Otter aircraft. For my part, we staged our survey from a Russian ice station near the North Pole, meant primarily as a base for exotic tourist activities. For us, it was a landing strip and accommodations. It was exciting work. For each station, the pilot would search for smooth ice, then do a series of touch and goes, each time applying a little more pressure to the skis, then circling back to look at the track to see if water had appeared. When he was satisfied, he would land. We would pile out, drill a hole in the ice through which to drop our instruments. And that little tent on the side is where the profiler is going down. Then pack up and repeat. The results were also exciting. We compared our data with similar surveys done by the Soviets back in the 70s and 80s and found that in those 3 decades there had been a major redistribution of liquid fresh water in the Arctic Ocean, with much of it herded toward the center of the Beaufort Gyre north of Alaska. Why was this important? The freshened water that piled up near the center of the Beaufort Gyre raised sea level there by about 35 centimeters, a little over a foot. The figure is color-coded to show sea surface elevation, with redder colors indicating higher elevation. The arrows show the currents associated with the slope of that sea surface. Around the southern edge of the gyre, the currents are 4 to 5 times as fast as they were before 2000. This in turn has swept old ice that normally would have gone toward the center of the gyre, down along the north slope, and then out into the western Arctic, which by late summer now is ice-free, where the old ice melts. This change has contributed significantly to the rapid disappearance of old, thick sea ice in the Arctic. Ice more than 2 or 3 years old used to be common, now it is rare. None of this was obvious when we embarked on the project in 2008. The survey we made then, plus subsequent measurements, provide a fairly nice example of how science works. We obtained an extensive set of observations. We figured the large changes we saw in those ocean measurements were related to climate. From basic oceanographic principles, we reasoned that the redistribution of freshened water would change circulation patterns in the Arctic Ocean. We then showed that the resulting change in currents played a major role in melting old, thick ice, creating more liquid fresh water. An unexpected twist on the ice albedo feedback. Observe, imagine, hypothesize, prove. The study provides one small example of how complicated the climate system is. Who would have guessed that clear out in the middle of the Arctic Ocean, we would find a region where sea level had risen by 35 centimeters in the time span of less than a decade, and that this in turn would feed back to accelerate the loss of sea ice. Most of us think of climate change in the context of the rise in global average surface temperature. But if you really want to understand climate, look to the ocean. Heat absorbed by the ocean is telling us that the radiation budget of the Earth is out of balance. That is, more energy is coming in than is going out, and if you want a number, that imbalance appears to be about 3/4 of a watt per square meter. The ocean has taken up 90% of this imbalance, which is really lucky for us. If all that heat had gone instead to the atmosphere, the Earth would by now be way too hot for human habitation. The heating is also melting the vast ice shelves of Antarctica and Greenland at rapidly increasing rates, which in turn accelerates the loss of continental ice. There's a fishing boat in that picture which gives you some scale, and it's good to remember that what you're seeing above the water is balanced by about 9 times as much mass below the water. This brings us back to the ice albedo feedback issue. Over the past few glaciation cycles, it appears that the albedo change associated with growing or shrinking continental ice sheets is just about as important as greenhouse gas concentration in determining the state of the climate. We might be able to arrest or even reverse the increase in atmospheric CO2, but stopping the loss of ice from Greenland and/or West Antarctica with the associated sea level rise is a much more daunting challenge. A while ago, I talked about the climate dragon going to sleep for the 10,000 years of the Holocene, and concern that small perturbations could awaken it. 2 centuries of burning fossil carbon at ever-increasing rates is not just tickling the dragon's nose, it's hitting it over the head with a sledgehammer. For more than 2 decades now, we have been watching the Arctic adjust toward a new, very different state. The nature of extreme weather events we have seen over the past few months makes it seem probable to me that the entire Earth, not just the Arctic, is in rapid transition. 20 years ago, I pondered the Earth my grandchildren would inherit with the tacit assumption that I would not live to see the major changes. I'm afraid that now it looks as if that assumption was wrong. Thank you.